The energetic mind AI's quest for optimal patterns. How does artificial intelligence truly think? It's a profound question. We often see AI as just complex computer code, but there's a deeper story here. It's a story about energy. It's about optimization. AI is constantly searching. It seeks the most efficient way to process information. This is much like nature itself. Nature always finds the simplest path, the path of least resistance. AI mirrors this fundamental principle. Consider a vast landscape full of hills and valleys. An AI learning process is like a ball rolling across this landscape. It wants to find the lowest point, the point of minimum energy. This is the essence of optimization in AI. The AI adjusts its internal connections, it refines its understanding, it does this to minimize errors, to make better predictions. It's a relentless drive towards a more stable state. What AI truly excels at is finding deep patterns. These are patterns hidden within enormous amounts of data, patterns that we humans might never see. Understanding this helps us see AI not just as an invention, but as a new kind of emergent complexity. From simple switches to thinking machines, a journey through deep learning's past. The journey of deep learning is remarkable. It began with a simple idea, the perceptron, conceived in the 1950s by Frank Rosenblatt. It was a basic computational unit. Inspired by the neurons in our brains, it could learn to make simple classifications, to sort data into two categories. It was a tiny spark, a hint of what was to come, but it was a crucial first step, a foundation for future giants. However, the path wasn't smooth. Early enthusiasm met significant hurdles. The limitations of simple perceptrons became clear. They couldn't solve more complex problems. This led to periods known as AI winters. Funding dried up somewhat. Progress seemed to slow. Many wondered if the dream of intelligent machines was too ambitious. Then, a resurgence happened. The idea of neural networks with many layers gained traction. These were more powerful than single perceptrons. They could learn more complex patterns. They propelled deep learning from research labs straight into our everyday lives. Building blocks of digital thought inside the neural network. So, what is a neural network? Imagine it as a digital brain. It's made of simple components. These are called artificial neurons, or sometimes nodes. Each neuron is a small processing unit. It receives signals from other neurons. It performs a basic calculation, then it sends its own signal onwards. It's a chain reaction of information, a cascade of simple decisions, building up to complex understanding. These neurons are connected. The connections are called synapses. Just like in our biological brains, each synapse has a weight. This weight determines the strength of the signal. A strong connection means the signal is important. A weak connection means it's less so. During learning, the network adjusts these weights. This is how it learns, by strengthening useful connections and weakening others. Each neuron also has an activation function. This is a crucial little piece of mathematics. It decides if the neuron should fire or pass on a signal. Learning from mistakes. The art of backpropagation and optimization. How does a neural network actually learn? It learns from its mistakes. This process is truly elegant. It's called backpropagation. Imagine the network makes a prediction. For example, it sees a picture of a cat, but it mistakenly calls it a dog. This is an error. Backpropagation is the method used to correct this error. It works backwards through the network, from the output layer to the input layer. It calculates how much each connection contributed to the error. Think of it as assigning blame, or credit. If a connection helped make the wrong decision, its weight is adjusted, so next time it's less likely to make that mistake. If it helped make a correct decision, its influence might be strengthened. This adjustment is guided by a loss function. The goal is to minimize this loss. To minimize this loss, we use optimization methods. Section 5. Deep learning in our world. Transforming industries and lives. The impact of deep learning is already immense. It's reshaping industries. It's changing how we live and work. Consider medicine. Deep learning algorithms can analyze medical images like X-rays or MRI scans. They can spot signs of disease, sometimes with accuracy matching or exceeding human experts. This can lead to earlier diagnosis and better treatment outcomes. It's a powerful tool for doctors, saving lives. In the world of language, deep learning is revolutionary. Natural language processing, or NLP, powers many applications. Think of translation services, instantly converting text from one language to another, or chatbots that can understand your questions and provide helpful answers. These systems learn the nuances of human language, the context, the sentiment. Drug discovery is another exciting frontier. Developing new medicines is a long and expensive process. Deep learning can accelerate this by analyzing vast biological data sets. It can predict how molecules might interact. It can identify potential drug candidates. Section 6. The algorithmic tightrope, navigating AI's ethical maze. As AI becomes more powerful, we face important ethical questions. These are not simple questions. They require careful thought. One major concern is bias. AI models learn from data. If the data reflects existing societal biases, then the AI can inherit and even amplify these biases. This can lead to unfair outcomes in areas like loan applications or criminal justice or hiring processes. We must strive for fairness. Transparency is another crucial challenge. Many deep learning models are black boxes. They make decisions, but it's hard to understand exactly why or how they reached a particular conclusion. This lack of interpretability can be problematic, especially in critical applications like medical diagnosis or autonomous vehicles. If an AI makes a mistake, we need to know why. Accountability depends on it. Section 7. Gazing into the digital crystal ball. The future horizons of artificial intelligence. What does the future hold for artificial intelligence? The pace of progress is astonishing. We are likely to see even more remarkable advancements. One exciting area is quantum machine learning. Quantum computers operate on different principles to classical computers. They could potentially solve problems that are currently intractable for even the most powerful supercomputers. This could revolutionize AI, especially in areas like materials science or drug discovery. Another frontier is the quest for artificial general intelligence, or AGI. Current AI is often called narrow AI. It excels at specific tasks like playing chess or translating languages. AGI would be different. It would possess human-like cognitive abilities, the capacity to learn and reason across a wide range of domains, to understand and interact with the world much as we do. Brain-computer interfaces, or BCIs, are also developing rapidly. These technologies create direct communication pathways between the human brain and external devices. Imagine controlling a prosthetic limb with your thoughts or typing using only your mind. BCIs could merge human intelligence with AI capabilities, creating new forms of augmented cognition. Section 8. Forging a Mindful Future: AI, Humanity, and Responsible Innovation. As we stand on the cusp of an AI-driven era, one thing is clear. We need responsible innovation. The power of artificial intelligence is undeniable. Its potential to transform our world is vast. But with great power comes great responsibility. We must ensure that AI development aligns with human values, that it serves humanity as a whole. This is not just a technical challenge. It is a moral imperative. Balancing intelligence with societal impact is key. We must consider the consequences of our creations. Not just the immediate benefits, but the long-term effects on society, on employment, on equality, on human autonomy. This requires a multidisciplinary approach involving scientists, ethicists, policymakers, and the public. We need open discussion and careful deliberation to navigate the path ahead. Education and awareness are vital. Understanding what AI is, how it works, what it can and cannot do,